good evening. My name is Toby, and today I'll be talking about Kid RSA. And before we get to that, so this is the content. I'm just going to run real quick. And it seems like, so I'm going to do a quick recap on RSA itself. And just from what the doctor said earlier, we have, so the major concept of RSA deals with choosing two big prime numbers. And those two big prime numbers are represented as P and Q. And just as we learned earlier, the phi of n can be calculated using that. And also, for the remarks, both P and Q, they have to be greater than or equal to 2 to the power of 512. So it doesn't mean that it can be more than that. But they're saying that's the least. And also, n, on the other hand, can be greater than or equal to 2 to the power of 10, 24. And I've actually seen bigger numbers, though. So, well, so here, don't get confused about the notation. K-pub just means public key, and KP of R means private key. And here we know that in order for us to choose an E, that E has to be within the set of 1 to phi of n minus 1, where E is less than n. So looking at this, of course, we know that phi of n here is P minus 1 and Q minus 1. Both P and Q are prime numbers. So apparently, this is going to become an even number, and this will become an even number. And if you multiply two even numbers, it's going to become an even number as well. So that tells us that phi of n will be an even number. So E of n does not necessarily have to be a prime, but it has to be an odd number. So, and to compute that, we just saw this recently, and I'm not sure if I should go ahead and do an example, or everybody is fine with the previous presentation. Do you want an example for RSA, or should I move on to the next one? Move on. So, today I'm going to be talking about Kid RSA. Quite interesting, simpler, a lot easier, and where I took the majority of my slides from came from a work that was done with high school students, just to show how easy it is. So here it says that, of course, it's a public key cipher system, and it was created by Neil Koblitz in 1997, and also is an asymmetric crypto system, similar but simpler than RSA. So what does this really entail? Now we know that in RSA you have both the way you choose your N, your E, and your D is actually how it's being computed. But in this case, it's a lot simpler to do that. So in Kid RSA, we have a value set as M such that M will take two numbers and you subtract one from them. Now these numbers, they don't have to be prime, they don't have to be even, they could be any integer. And so for Kid RSA, you have to choose four different values, four integer values. It doesn't matter what those, there's no constraint on those four values. So if you choose the first value, the first two values as A, B, you generate an M, and if you choose two more, you use these two more to compute E, D, and of course N is being computed just using E and D minus 1 divided by M, where M is what we generated over here. So, well, the first question that came to my mind is, why do we really need all this? Well, now if you look at it, what is the difference between this Kid RSA and what an RSA that Doctor just talked about? So we notice that in RSA it deals with a lot of exponentiation. So imagine you have like, say you have 17 to the power of 30, 20, 26. If you try to compute that on your calculator, it's going to tell you it's a math error. And that's because the values are too big. But actually for this purpose, now the purpose of Kid RSA is to teach high school students a different way of a concept of RSA, but in a different computation. So as we're going to see later, and of course we have the public key to be N and E, and the private key is D and N. I omitted the N. Sorry about that. So now, how does the encryption and the decryption phase works? In RSA, this will be x to the power of E mod n, and that's exponentiation. But in this case, instead of using uh, e to the power of p or p to the power of e, rather, they're using e times p. So now when you do that, when you write a program for that, it's going to reduce the computational time by like a huge factor. Because this is multiplication, and what we had earlier was exponentiation. So for instance, if we have p to the power of e, where p is 17 and e is like, say, 3065, for instance, it will take the processor a longer time to compute that as compared to just saying e times p, because that's just one multiplication that you have to do. And also for the decryption part, we take the c and then we multiply it by d that we've already generated from the previous slide. And the plain text, of course, it has to be numbers, and it has to be between 0 to n minus 1. And the plain text or blocks of plain text has to be converted into numbers, just like I said earlier, in order for this computation to be feasible. Now, E and N is public, meaning you can send E and N to anybody. And once they get this, they can use this to encrypt using the Kid RSA, and then you can decrypt using the D that you already know. Now, an example of that would be, so in a case whereby you have A as 9, B as 11, and I used A prime, but it doesn't mean that this A prime is the inverse of A. Like I said, you just choose any four numbers. So from what we saw earlier, we calculate n by saying A times B, where A in this case is 9 and B is 11. So 9 times 11 will be 99 minus 1, that'll give us 98. And in order to calculate E, we take the other part of the two integers that we generated, which is A, we multiply that by M, and then we had the value of A to it. So it's just like, well, I'll probably not say that because I'm not sure. It's a different culture. But way back in Nigeria, there used to be this math question whereby someone would tell you to choose your name, your age. Don't tell them, but then multiply a number by that age, add a number to that age, and tell them what the result will be. So it's just a way of confusing the mathematics. But eventually, whatever you choose here will still generate the same thing as long as both four integers are being known. So in order to calculate n, we have e times d, where we've already calculated e and d over here, and that will give us 4048. So, and also two things that I realized, the two major difference I realized between the Kid RSA and the RSA is that for the RSA you deal with exponentiation, and for the Kid RSA it's multiplication in terms of how you encrypt and how you decrypt. And these are the references and any question and answer. So see Kid RSA as a high school version of RSA, whereby all you just have to do is play with other integer numbers. You don't have to do anything out of the ordinary. All you have to do is choose four numbers, four different integer numbers, use two of them to do the first part where we got the m. You just multiply both of them together, you subtract it by 1. And in order for you to generate the n, which is the modulo, all you just have to do is e and d, you multiply e by d, you subtract 1 from e and d, and then you divide it by m. And m itself had already been generated earlier. So I don't know if this makes sense. But
that's so the chosen number has to be in neat numbers, discrete numbers.
Yes, you can choose the same number. Like for instance, you can choose A and A prime to be 6. That's not going to be any security.